Uh, Good evening, everybody. Welcome to day 4 of AETSEC ATAL-FDP hosted by IIIT Kottayam. So today, as the first speaker, we have Dr. Ambika H. Dr. Ambika H is Assistant Professor, Department of Civil Engineering at IIT at Hyderabad. Professor Ambika heads the Greens Research Group at IIT Hyderabad and is also adjunct faculty at Greenco School of Sustainability and Department of Climate Change. Dr. Ambika is recipient of the prestigious Wari Fellowship at University of Nebraska-Lincoln during her PhD at IIT Madras. Professor has completed more than 20 projects as consultant. The Greens Research Group headed by Professor Ambika focuses research on novel nano or nanostructured materials, processes, and systems designed to treat polluted air, water, and soil environments for achieving a sustainable development. We welcome you, Dr. Ambika, for delivering the talk. I think.
Yep, thank you. So let me share my screen.
Okay, yeah, you can check.
Can you see my screen?
Yes, madam.
Yeah,
Yes.
yeah, it's visible, yes.
Oh, okay, thank you. Thank you for inviting me. So the talk is going to be on AI in waste management. So basically, I'm an environmental engineer, and it's my voice and everything is clear.
Yes,
Yes,
madam.
yes,
Everything
audio,
is clear.
yes. Ma'am, you can turn on your video also if it's okay.
My video is not working somehow.
Okay, okay, no problem. No
Fine,
problem.
madam. Please go
Okay.
ahead.
So I'll just yeah.
If possible, maximize this. Yes, madam. It's
Yeah,
very
yeah,
clear.
now it's okay.
Okay, yep, thank you.
Please
So
go.
the talk is going to be on AI and on waste management. So basically, I'm an environmental engineer. So I do a lot of work on water, wastewater treatment, waste management in the aspects of technology development and the technical analysis more than the implementation of AI. But because the talk is going to be on AI, I try to recollect the projects that we have done and we are working now and the consultancy work that we have done for multiple things, and I try to include the aspects of AI in all those projects. Also, I have collected few informations from publications, few other publications, that there is no connection between me and publication. That this is the disclaimer before I start the work. So just to get an idea of what I am doing, so so this is my website. So because the participants may be from different background and from different institution, so to get an idea of what kind of research we do at IIT Hyderabad, I just wanted to showcase this website. So anyone can search Ambika, Google. So you can end up with, you will end up in this Google site. So you can see, so basically, as Madam has introduced, so I'm heading the Greens group, and I am also an adjunct faculty. Other than, so civil engineering department is my parent department. Also, I'm an adjunct faculty in Greenco School of Sustainability, under which we do offer two other programs: MTech in Sustainable Engineering, MTech in E-Waste Resources Engineering and Management. So I was the previous coordinator also for this MTech E-Waste Resources Engineering and Management. That means we take care of all the curriculum, revision, teaching, research, laboratory development. So it is like a HOD position for that particular MTech department. I am also an adjunct faculty in the Department of Climate Change. Also, I'm an associate editor for the journal ASE Journal of Hazardous and Toxic and Radioactive Waste. And so the focus research area of the group is of four. So environment and energy, pollutants of concern, climate change and sustainability, waste management and circular economy. All these are kind of interconnected, say environment and energy. So there we deal with pollutants of concern and different waste management. When we do waste management, we talk about climate change and sustainability. So these are kind of very much interconnected. And I do work with people who are having different backgrounds. Say my core background, environmental engineering, people from MSc Environmental Science, chemical engineering, chemistry, mathematics, sociology, core AI people. So I do work with multiple groups and interdisciplinary departments for the efficient communication, analysis, and application of my research. So to just to give an overview, so I do work on nanomaterials and nanomaterials based products that can be used for water, wastewater treatment system, waste management. We do develop sensors for pollutant analysis. So we do work with multiple phases of pollutants, water, wastewater, air, solid state pollutants, and different pollutants of concern that includes emerging contaminants. And so in the respect to climate change and sustainability, so we do a lot of life cycle analysis, agri, health, environment aspects. So we have started this AAML in air pollution, AAML in air pollution and health, AAML in climate change and health and air pollution. And one of my PhD students, so he is working on agriculture and health, agriculture and pollution. So he is also kind of trying to collect the data and apply AML models to predict the pollutants, to predict the future synergy. So these are few things that I wanted to highlight, and because the talk is going to be on waste management and circular economy, so few of the projects that we have already completed, so I will discuss during that itself so that you will get to know. So we do deal with agriculture waste, e-waste, resource recovery, biochar, developing different circular economy indices to measure how much is actually how deep we are moving towards circular economy. And the group used to have a lot of open vacancies. So as of now, we have vacancies for PhD, postdoc positions, project positions, and we do hire interns for summer and winter also. The students used to come here, stay with us for 1 full year, sometimes 6 months to complete their MSc thesis or MTech thesis, sometimes BTech thesis. So depends on the institution and the student's interest. So let us come back to the presentation. So you can visit my website. Where can I keep this? Because I think this is okay. Keep it somewhere, or can I hide it? Yeah, I think it's hidden. Okay, so this is my website. So if anyone wants to know more about any of the open position or the research that we are doing, are interested in joining in our research group, you can write to me. This is my email ID. So with this short introduction of the group, I just wanted to go directly to this waste treatment versus management. So when it comes to waste, there are two terms that are being used in a generic way. The people who are from environmental engineering background, they will be having a clear-cut idea between what is treatment and what is management. But the people who are from the other discipline, so for them, I just kept this slide. So the definition of waste is multiple things, like multiple definitions are given in the past 25, 30 years. But when I teach to the students, this is how I start. So nothing is waste when it is kept at the right place, right time, or with the right person's hand. And any resource can become waste when it is kept in the wrong place, wrong time, or in the wrong person's hand. So this suits for every substance under the sky. And when it is about the treatment, it is just the removal of unwanted items. Say in water treatment, we don't call it as water management, water treatment, because water has pollutants that are having some concern towards ecological health and human health. We want to get rid of those pollutants. So we are having these water treatment units that removes individual pollutants of focus. So we call it as water treatment. Similarly, any technology that is focusing on removal of unwanted substances from solid waste or any waste, so then we call it as treatment, whereas management is a complete perspective, a comprehensive perspective on how to plan, how to make decision, how to organize, how to recruit a good staff, how to train the staff, how to lead and control to reach its goals efficiently and effectively. So this is what we intend to work towards solid waste management or any waste management. So what is this goal means? This is the hierarchy. So basically we want to reduce the waste, we want to reuse the waste, we want to recycle and get product out of the waste, we want to recover the resources from the waste, we want to dispose it safely. So these are the goals that I am talking about here to reach efficiently and effectively in its best. And when we talk about waste management, so all these things we need to think. So before planning, before decision, before organizing, before recruiting a staff, before training a staff, we need to look at all the perspectives in this criteria, right from reduction to disposal. And the most desirable option always used to be the reduction. And the least desirable option is the disposal. That means if there is no other option to reduce, recycle, recover, then we go for disposal. So we need to work towards zero disposal of waste, or in other words, completely make the waste generation of zero. That means reduction to 100%, or reuse, recycle, recovery 100%. That means that 100% of everything comes back into the system of manufacturing or in the supply chain. That is what its ultimate aim is. And when we talk about this resource recovery portion, so reduction is something that we have to work on our lifestyle. We need to work on multiple awareness programs. We need to start the elements in the flow chart of supply chain right from the manufacturing process, say the cloths. So we may need to, so for a long time we use cloths, then it becomes, once it becomes the condition that we cannot wear it in a proper condition, then we use that cloth for other purposes at home. So even when someone is uneducated, still they can think of this waste reduction in multiple perspectives. So they use it to the core before throwing it out. So the moment they decide to throw it out, that means that it is no more of in use. So it has to go to disposal site. But how to make it zero? So it may go to recycling unit, where the textiles are recycled and extract the fibers, trying to make new cloth out of that, or trying to make new product out of that. So there we are moving towards the complete closed loop of circular economy. So when we talk about this resource recovery in waste or solid waste, there are two things we can recover. One is materials, another one is energy. So just to get an idea, materials means it may be water, metals, nutrients, fertilizer, pharma compounds, dyes. So it can be anything of substance in nature, mass in nature. Whereas energy, it can be direct energy recovery, indirect energy recovery. Direct energy recovery, you must have seen anaerobic digester in most of the hostels, biogas plants in multiple food industries. So here the biogas and the thermal energy is kind of directly derived from the waste processing unit. So this comes under direct energy recovery. Whereas the thermal energy is used to heat the water. In that case, that becomes indirect energy recovery. So all these are just to give an idea of what is the difference between waste and resources, treatment versus management, the hierarchy involved, and the resource recovery that are being involved in the waste management system. Then comes the linear and circular economy models. So the linear economy is the flow of system. The supply chain used to be linear in nature. That means that there is no reverse, or there is no interconnections between them other than the flow of materials from one element to the other element in the flow. So here you can see, say we wanted to have a mobile phone. So all of us are using smartphones. So this smartphone, if you see, there are multiple components, multiple parts are being manufactured. I'm hearing some background noise. Can you please make sure that that is being turned off? Okay, thank you.
Yeah, madam, sure. Thank you.
Thank you. So this smartphone, if you see, it may have multiple metals, minerals, semiconductor materials. So it all starts from the resource extraction, mostly the mining activity end up in these resources. Then we do multiple processing to end up in say gold, titanium, palladium, so that are used for mobile phone manufacturing. Then the production process, so that involves arranging all the things and manufacturing individual components, say IC, RAM, everything. Then the distribution system, so this is where our people comes, so it will be distributed from the industry's gate to multiple retailers. Then the customer, we the users, we go buy the mobile phone and we use it. So then it becomes the waste here depends on people's perspective. Say still people are using this phone for more than 15 years, 20 years. People are using the phone for only 1 year or 2 years. So when the next iPhone gets launched, people wants to buy it. So what happens to the previous phone? So that becomes the waste, or it goes to refurbishing unit, it goes to reseller. So there are multiple ways it can come back to the system, but when it becomes the waste and it goes to the dump site, we call it as linear economy. Whereas the things are reused, refurbished, remade, or recycled, so that this resource extraction can be reduced even 10% or 1%. That means we are moving towards the circular economy. So this is the basic difference between the circular economy and the linear economy. So when we are talking about waste management, it is all about the circular economy. When it is about the waste treatment, it is more of not including the concepts of circular economy. So the circular economy concepts are the waste management concepts. Generally, it not only talks about eliminating the waste, which is the treatment part, but also the continual use of resources in the entire system. So this further ends up in minimizing the resource inputs that are needed from this resource extraction, impact on environment, impact on health risk. So the same thing again, generally the waste can be reused. So before it goes as the waste, before it is being disposed, it can be reused. It can go back to the remanufacturing or refurbishing units. It can be going to the recycling units or recovering units, so that we can end up in multiple products or substances that can be again go as a flow into the different production and manufacturing unit processes. And when we are talking about this circularity or the closed loop system or circular economy, we always remember that it has to be a single cycle. So say here, it is a single circle. So we assume that if it is not happening in a single circle or single closed system, then that becomes open system. Open system is this linear economy system. But the truth is, when even we are simplifying with one circle, uh, it is not as simple as what we are saying. Say plastic waste. This is the simplified version of plastic waste management. This involves at least two circles you can see here. So say plastic is being generated, and you can see there are different types of plastic that can be recycled to make it as a new t-shirt or chair or whatever comes back to the home. So now your home is kind of having the primary plastic and the products that is made up of secondary plastic. That means it is processed at least one time. So this is one loop where the plastic waste is going out of the house and coming back to the house with a new avatar. The other side, so there are few plastic types, there are few plastics. Say there are multiple times we are recycling. So at a point of time, it may lose its basic characteristics to mold it as a new material or new process or new product. So in this case, so it is no more recyclable. So non-recyclable plastics takes another loop. Another loop, it is generator where thermal energy is being generated, and it can get converted into energy, electricity, and it can again come back to your home. So that's what I was telling in the previous slides also. The recovery is majorly divided into two: materials recovery, energy recovery. And when I was talking about the circular economy, again I have mentioned it is not always one circle, it can be more than two circles also. So in plastic waste, the simplest illustration at least has two circles, but it is not that simple as what we are seeing here. The first circle, A circle itself, has multiple small and sub-circles if we are studying in detail. So why I am showing all these things? Because we are going to talk about AI, we are going to talk about the data that we require to do all these things, because we are talking about not only the treatment portion, we are going to talk about the management portion, which involves multiple data and multiple complex system analysis. So that's why we are talking about all these things. Okay, so then comes to what we are doing in my laboratory. Okay, so if I show a few projects that already being completed or ongoing, so I can easily connect it with what is the requirement of AI here. So I try to explain these things from the slide one. So here it is about the e-waste management. So again, when it is about management, it is not only just the removal of pollutants because of e-waste, it is about how you are managing e-waste with a hierarchy to move towards zero disposal. That is the ultimate goal, and reduction of e-waste. So these two are the ultimate goal. So here we have worked on recovery of the substances or useful substances from e-waste. So generally we do target precious metals, because when we recover the normal ones, the resale value becomes so low, and the process cost becomes more. So basically, when we do this balancing our cost benefit analysis, we should fall under the profit category to make any technology successful. So this is something that we have done. We are working with multiple e-waste like PCBs. We have started with PCBs. We are working with RAMs. We are working on lithium ion battery. So we are working with multiple waste products, and we are trying to work on recovering different substances. So this is a simple procedure that we have followed, and we have collected the sample analysis, and this is the second method that we have followed. So what is the difference between these two methods? So the first method is just to shred and try to leach the important substances of focus. The second one is targeting the specific components and try to recover the focus materials. So there is a huge difference between the efficiency, especially the recovering of the target substances. Say the first one, if it ends up in 60% of recovery, the second one, it could end up in more than 88% of recovery. So this is what we have understood from the laboratory experiments. Now, how to apply AI here? So it is basically when it is about e-waste. So the major problem is the layering. So e-waste, you can see they have arranged multiple components on any board. Say PCB board, you can end up, you will be having multiple components like IC, the anode, many things are there, the charging port. So, and this PCB, for a washing machine, the PCB is different. For a laptop, the purpose of PCB is different, and so the materials involved. For your desktop, PCB is different. So for everything, the PCB's role is different, and so how it is kind of arranged, how it is kind of layered, and what kind of materials, what quality of materials, purity of materials is being used. So this ends up in multiple types of PCB, that ends up in multiple ways to work on it. So we need people who can involve or who knows how to apply AI and try to connect with the basic components of different types of PCB and so the substances that are being available. Because the main problem is substance should be available to recover. So here the AI's application not only involves in the decision making of which precious metal is available in which part of PCB, which type of PCB, but also the second portion is about the selection of treatment technique or the selection of the recovery technique to recover which kind of pollutant it is. So basically it requires a lot of data. So basically we should know what is the PCB that we are working with, what are the different types of PCB that we are working with, and what are its different components, where is it sourced from, what are the substances that we want to recover that, what are the different processes that can be used. So all this has to be feed in so that the AI or ML can give us the optimized the output or the best output that can help in decision making. So this is from the very first project that is being carried out in e-waste. So one of my PhD student, his work is specifically on resource recovery from e-waste. So there are 2 MTech students and 3 interns. They are working as a group on e-waste management, and the next one is about the carbon mass recovery from waste. Specifically, we have focused on graphite. So here we have not only recovered the graphite but also checked for its secondary application for the same purpose or for different purposes. So here also the AI can be used in figuring out what are the different carbon mass that can be extracted, and their characteristics can be fed in from the laboratory results so that we can make a module or a system which can give us the optimum results of has to be fed in as the e-waste material so that we can get the pure quality or the secondary quality of graphite waste that can be used for the other applications. So when it comes to the another project, so this project is basically on groundwater treatment system using the iron waste. So there are multiple metal waste that are being wasted from different industries. We try to connect the treatment of the polluted water. So when we are talking about polluted water treatment, we always use raw materials, virgin materials, which needs lot of extraction and processing. So we thought, why don't we use some waste material to recover the pollutants or to remove the pollutants? So in that way, we started this work, and there is something called permeable reactive barrier, which we fill the reactive substances, the reactive materials that can take care of the pollutants. So here we have worked with multiple types of iron. So it is not only iron. So you can use multiple substances. Say aluminum also does similar function, but that ends up in secondary sludge or secondary pollutants. So here a comprehensive assessment or a model is required to understand for which type of pollutant, what type of material we need to use if we are selecting a particular technique, and that ends up in what kind of secondary issues. So once the waste is being generated, once the waste pollutes the groundwater system, polluted is polluted, we cannot recover it 100%, and you cannot avoid you cannot avoid the production of secondary sludge or the secondary treatment products. Say here we have used iron as the material. So it will efficiently remove the toxic pollutants. But at the end, we end up in maybe say 5% of iron as the sludge. That needs further treatment. You can again you need to excavate the system or you take care of it, or you can leave the system as such because iron's toxicity level is very much higher compared to the other heavy metals toxicity. The limits are higher when I'm quoting the word toxicity. So here also we can have multiple AI modules to understand how much nano. Okay, so when it is nanomaterial, it can be 20 nanometer, it can be 40 nanometer, it can be micron scale. Micron scale again, there are multiple sizes. So depends on the pollutants. The more details we go, the more energy we need to spend. The more pure the chemicals should be used for manufacturing such things. So when we go for field application, we end up in having huge amount of this kind of materials, not just 100 gram or 200 grams. It is going to be kgs. So to reduce the secondary impacts of any such things, so you may need to apply ANML, and that may help in making the decisions which can further reduce lot of emissions and the secondary waste. So the next this project, so this industry came to us with this graphite waste, and they do generate 8,000 to 9,000 tons of graphite waste in Chennai, and they wanted to have some things, some products or some benefits out of this waste that is being generated. So we tried making multiple materials out of this graphite waste. So, and we try to apply it for energy production. We try to apply it for pollutant removal in water treatment, because that region is heavily contaminated with multiple pollutants. That includes electroplating wastewater, tannery wastewater, and textile wastewater. So we tried working on multiple directions to figure out which is the best approach. So here again, a lot of data, say the graphite waste which is being generated, it is not going to be homogeneous in nature. The characteristics changes. So we try to see what are the different characteristics of this graphite waste that is being generated on daily basis, and that can be made as a bank, a data bank, and then what kind of material that can be made out of which characteristic graphite waste. So that itself can be a small AI module or a model. So that will give an input. So the moment you keep the graphite waste in the in the ATR FTIR, so that will end up giving you the characterization. So when we have the feed-in data of which characteristics can end up in which product, so directly you will get a information about what product that is being, or what product can be the best product conversion from this graphite waste that is being generated. So this is the simplest model that we can develop. We can go for the complex model system also, depends on how many details that we are including, and what kind of output we require, and for what purpose that output is required. And the another work that we have done is, this is one of my master's students' thesis. So she has worked on the comparison of agriculture and plastic waste to make the similar kind of material that can be applied for again the pollutant treatment and energy recovery. So she tried to collect the agriculture waste. She collected plastic waste, types of plastics, to convert that material to the useful material. So here itself the AI can be applied, and when she tried to apply this product to different pollutant removal, so again we got different percentage of removal. So this is an example of a complete complex system modeling that involves a lot of input, like source of the waste, and what kind of waste it is. When we are talking about plastic, we are having multiple types of plastic, and every plastic doesn't end up in the same product, though we are following the same processing or the treatment system. So it ends up in the product which has different characteristics. So when we are trying on one pollutant, we may feel that one particular product gives the best result, and the another product does give the worst result comparatively. But when we are trying with different pollutant, the results may completely differ. And when we are trying to work on energy recovery aspects, again it may end up in a different ascending adder, which is totally different from the previous version. So there are multiple things that we need to think of when we are solving this complex system modeling, and when we are trying to execute these things in the laboratory, that ends up in 100-200 experiments. But with some basic experiments, if someone can develop AIML models to solve these kind of problems, that will be saving a lot of resources, energy, and that helps in making the quick decision also on what to really try in the laboratory. Obviously, the disclaimer is you need to have enough data to feed in the model. So generally, when we are talking about waste management, so I have worked in a project whereas this Ministry of uh, Housing and Urban Affairs, MOA, so they have this smart cities mission. So they have selected 100 smart cities, and in 100 smart cities, they have worked on multiple projects that include solid waste management also. So as a part of that project, we have learned few things. I'll quickly share that experience also. But before that, I just wanted to give a overview so that you can understand that projects as well. So generally in AI in waste management, so that can be on 5 different systems. One is like a smart waste management system that, okay, basically it's all about waste type generation, analyzing the chemical composition of waste, so that we can end up in understanding whether it can be used for waste to energy conversion or optimization, pyrolyzation, biological and fossil carbon in solid waste. So all these are basically depends on the chemical analysis. Then it is about the transportation. So what kind of logistics we require for the transportation, identify and mitigate the illegal dumping. So all these are related with the transportation. Next is about the waste management. So that is what I was talking about, the 5 steps: reduce, recycle, recovery, and finally it goes to the dump site. So there also I have given multiple examples from the projects that we are doing in my laboratory itself. Say I have shown you the recovery project, I have shown you the reuse project. So this is reuse project, and this is about again the conversion. Okay, recycling project. So all the 3 projects I have given examples. So every time I have explained how the AI or ML can help mitigating the problem and helps in managing and figuring out the best solutions or optimum conditions to apply. And the ultimate aim, as I told, it is always about the zero dump site, zero waste in the dump site. Or the another problem is always illegal dumping. So this A in waste management can be in each and every step in the hierarchy. So just to give an idea. Okay, so if we go deep, these are the 2 problem statements that I could see in most of the publications. So we are not working on garbage sorting, or our research group is not working on robotic waste sorting. So these details are completely collected from literature, because I have seen a lot of publications and a lot of people are working on the coding or the hardware related to these 2. Okay, so one is intelligent garbage system. So that includes gas sensor, temperature sensor, multiple sensors. So here what happens is it can improve the recycling efficiency and reduce the contamination. And the another side, it is about waste sorting robots. Okay, so it is about the robotics arms to sort the waste in recycling facility that further enhances its speed, accuracy, and everything. So here I just wanted to quote one more project that we try to work on. So there is a waste management facility in Goa, and they are using this belt conveyor. And so when this waste is conveyed in the belt, so both the sides people stand and they try to pick up the important material that can be recycled, say plastic. So now what they wanted to do is they wanted to set up a system, and that system can figure out only the plastic waste. Okay, so these kind of things are already being established in foreign countries, but in India, the system is they are trying to apply, but the system is not functioning as they have expected. They have tried to install a system. So here the plastic waste the plastic waste has to be separated from the entire waste stream, which has aluminum waste, metal waste, wet waste, many wastes, the paper waste, many stream. In the stream, you can see multiple types of waste. Among that, only the plastic waste has to be separated. Now, that system functions to an extent with the multiple inputs from my colleagues in AI department and computer science department. Now they came with the second problem statement. The second problem they wanted to they wanted to attempt is, so when we are doing this plastic waste sorting, all the plastics come into one bin. Now they wanted to segregate the plastics based on its type. So they don't want to have a second belt conveyor where these plastics can be fed in as the waste stream where it can be divided. They wanted to set up a system where in the main waste stream itself, the plastic waste is being segregated according to its type. So that means we need to have a system where the system identifies the plastic waste based on its type, and it has to segregate accordingly to the bin. Say 6 types, so 6 bins. Now they try to go for the optical based optical based sensor systems. So where the yes.
अरे असली यार नकली थोड़ी मिलेगा इसी की दुकान पे दे देना इसकी खत्म
Dear participants, please.
Okay. So
Hello. Hello. IT support, please make mute to all the participants. This is the second time we are repeating. This is not the correct. Please go ahead, madam. Sorry.
So yeah, so they wanted to install the system and they tried to start with this optical based sensor, but somehow it did not give good results. So so at that moment only I started involving in that project. Very beginning it was there. Then when they kind of end up in successful results, I was not no more in that project because it is more of AI and ML experts. So when they try to solve the second problem, they wanted to know what is the major issue, how to develop the system. So I try to give my expertise. So they try to develop the sensor based on whatever the input that I have provided, and they could success at least 50% more, additional 50%. But still we are working on it, and there is a center of AI also we have had in our IIT Hyderabad. And the next work is about the network structure for solid waste management. So generally when we have, this is something related to the first one only, the garbage bin example only. So the garbage bins used to have the sensors, and that gives the data to this network interface. So now it will upload the information to the network, internet and the users. Then the controller can take care of the things, and finally it comes to the sensors perception. So this is like any sensor network system for solid waste management. And the another thing which I wanted to highlight is this COVID-19 pandemic versus solid waste management. Why this is? Because every time we end up in an unusual situation, say an anomaly in our daily life. So during this COVID time, those years are considered as, if you see the data, a lot of environmental data and even the traffic data and many other data becomes like anomaly if you because of the social lockdown that was being involved in this COVID-19 scenario. Say the pollution drastically came down, the water becomes so clear, and the waste is generated hugely. Food consumption was kind of at the peak because everyone was at home, everyone was eating, everyone is generating a lot of food waste, a lot of solid waste. Solid waste generation was different, solid waste picking and sorting was different, and the way it ended up in the dump site, the data are totally different from a regular attempt. So those can be considered as anomaly data when we are trying to predict or forecast the future things. So now these kind of anomaly data also need to be taken care by the AML expertise. So why? Because a few things you cannot just consider as an anomaly data when the moment comes. Say COVID-19 that end up in a lot of waste that are risky to touch because they had all the characteristics to kind of spread the infection from one person to another person. So that is the reason many kind of stopped involving them from waste management related works. So then what happens? It ends up in huge amount of waste that anyhow we need to deal with that. We cannot just avoid it. We have to deal with it. So this kind of unique situations also has to be modeled. So I have just included COVID-19 as one of the unique situation that we all aware of, that we all can connect it with. So again, coming back to the project that I was quoting under Smart Cities Mission. So under this project, we have visited different sites in these 5 cities: Indore, Surat, Pune, Lucknow, Cochin, and we try to talk with people in corporation. We try to talk with IAS officer. We try to talk with the people who are involving in services like NGOs. We try to talk to public. We try to talk to the engineers and the people who are in this corporation office. And even we have tried to talk with the people who are in the lowest hierarchy in the waste management sector, say the people who work in dump site, or even we talked with people who are rack pickers, who try to sell their items to some scrap shops. So we try to talk with the people and try to understand the system completely to understand the effect of the smart cities mission, or the impact of the smart city missions on their daily life, environment, and their financial conditions. And how is it connected with the AI? Because they have implemented something called this ICCC, that is Integrated Command and Control Center, where so whatever I have mentioned here, the sensor perception, waste sorting robots, and the different things that they are trying to recover from the solid waste. So that is kind of, so it is not only about the solid waste. They have included transport data, they have included air pollution data, they have included multiple things in this ICCC system. But the this, because this talk is going to, I mean, this talk is focusing on waste management, I try to talk only in the waste management perspective. So here all the data are collected through sensors, and that has been stored, or that has been used from this ICCC module. So if someone needs the data for how much of waste is being generated from a particular ward or particular district, so we have the data available, they have the data available. And how much fuel, so transportation, for example, morning the people has to come and collect the door to door system, like every door they'll collect the waste. Then you must have seen a small truck, so they'll collect all the waste in that truck. So these trucks again go and dump all the waste into a bigger truck. The bigger truck is something that we can see in the roads. And so now if you see fuel efficiency, so the small truck also need to be filled with fuel, and the bigger truck also need to be filled with fuel. So they have mounted a small sensor to check the fuel efficiency of that vehicle and the volume of fuel that is being filled. So why they have to do that? Because there are a lot of fuel theft in the name of solid waste management collection. So they have mounted this fuel. Now there is no more such tricks can be played. So that saved a lot of funding from this corporation system. So this is one small example where this AI and ML could convincingly plays a major role in directly into the money terms, because when it is about the fund, people really do care, whether it is government system or people, they really do care. And the another problem that most of the corporation officers feel is the attendance. Okay, so say in Hyderabad municipality also, even in Chennai municipality also, so they have this problem. Both are I mean they are metro cities, so they have this problem of handling huge waste management. So every morning they have to deal with the laborers who are working in door-to-door collection system, or the vehicle, the drivers who come and collect the waste from multiple locations. They have to work on different routing problems. So because they have to take different routes, and everything has to connect or contact with each door. That is the major challenge. So again, this is a complex system modeling. So they wanted to develop an attendance system, auto attendance system, or they wanted to develop a system where this garbage waste is hugely generated where it should not be. Say a person who is selling tender coconut in the roadside. So you must have seen they used to keep a heap of used tender coconut after drinking the water, they just keep it and they leave. That means that particular location is not to be meant to collect the waste. We don't need to collect the waste. The city office doesn't need to collect the waste from that location, but they end up in collecting that waste, because we do not have a system where the penalties will be on the roadside shoppers also. We have the system, but the implementation was really poor, so they try to use that loophole. They end up in having generating multiple heaps of such waste. That is the burden for this corporation office. So they wanted to do something for these problems, to overcome these problems or to get rid of these problems. So when it is about waste management, there are multiple options and opportunities that are available in terms of the efficient waste management system. So we have given suggestion also after looking up after doing the field visit to all these 5 cities, and that is one of the important thing that we have included is this ICCC system, that is the integrated command and control center, implemented across all cities in India, and that has to connect the multiple perspectives of waste management. So here I just take a break and just I want to overview of what we have seen before going to the next one. So we started with what is waste, what is the difference between waste and resources, what is the treatment and management, and the different types of resource recovery, and I have explained what is linear and circular economy, and which each of these I have explained how the AAML can be connected. And next I have started what we are doing in the laboratory. So I have given 3 problem statements. One is for recovery, for recycle, another one is for reuse, and how the AEML perspectives can be applied here as a practical thing itself. And next I started talking about few things that are continuously being implemented, and lot of publications are there, a lot of people are working on it, still have lot of implementation related issues, and I have shared my experiences with the Smart Cities mission and a few of my other projects. Now the next work, it is also about it is a compilation of a few other things that we are doing. But I have mentioned, we are developing the indices that are related to the circular economy also. So that again has to include like air pollution index. So when we are talking about air pollution, there is an index called the air pollution index, which has few pollutants concentration as the input, and there are some calculations involved in that. Similarly, we can generate, there are multiple indices for measuring the circular economy aspects. So another one is sustainability assessment. So when we are trying to implement different technologies, there is a compromise. There is a compromise between society, environment, and economy. So which needs to be compromised, which needs to be focused on. There is something that AML can help in. And there are few models that are available in the environmental perspective when it comes to pollution treatment or waste management strategies. But uh, these models are really deep enough to tackle most of the problem statements. But when we are trying to include the complex system modeling or the complexities involved in that system modeling, definitely AAML plays a major role. And the mixed pollutants removal or mixed waste management, that is another major problem statement that is still being, that needs a lot of addressal. So next what I'm going to do is just I want to give a overview of what is the opportunity and challenges that are being involved in AI and waste management. So here I have split the contents into 5, 6. One is research and major 3 problems when it is about AI in waste management. Second is about technology. Third is about economy, society, environment, legislations. So here the third, fourth, fifth points are the basic pillars of sustainability: economic sustainability, social sustainability, environmental sustainability. The first 2 are about the research and technology, that the researchers are being involved, the engineers are being involved. The 6th one is about the policy related things, whereas the government is being involved, and the 1, 2, 3, 4, 5 will give the input for the legislation portion. So when it is about research, when it is about the assessment of research on anything, generally it is measured in two terms. One is publications, another one is patents and commercialization. So if you see both are kind of exponential trend, like the trend is kind of continuously increasing, and so that means there are a lot of chances that we are having on environmental pollution removal or environmental waste management. So this field is going to be forever, because every day we end up in having at least one new product launched in the market. Whenever a product is being launched, you can make sure that one or another day the product's lifespan ends, it comes to the waste bin. So now it is about the waste management, whether it has to be directly dumped into the dump site or how it has to be processed so that efficient management happens. So every new product will give an opportunity for the waste management person also. So that is the major thing that we have to look at. So even you can see this EMS. So they have their stock was really doubled the past few days itself, just because they are new projects. So these waste management companies, the pollution treatment companies are really picking up, and we need to develop a lot of technologies which can end up in profit making, okay, with less effort, with lesser impact, of course. So these are few journals that many of the waste management people who are kind of researching on waste management publish their result. It is also kind of continuously increasing, you can see that. And when it comes to countries, okay, different countries, again, this is 2021 data. So India is in fourth. Even then we can call ourselves in fourth. You can see the huge difference between the people who are in the first, second, and third. So third and fourth, UK and India, the difference is not that much. One is around 700 and one is around 600. So it is like 200 points are different. But when you compare United States and China, you can see at least there is a difference of 1,000 in between them. And when you see China and UK, China or India, you can see we are like 1/4 or 1/5 of what they are doing in terms of the respective units. So the problem is here, new findings versus publications. We make a lot of findings, but we don't publish. We don't document it. We don't convert them to a technology. Our funding opportunities are really less. Our researchers' mindsets are like we are still figuring in settling our life. So basically, when someone has the feeling of settling, then they may start looking at the publication, technology conversion, and everything. Till then, you cannot expect them to be. And a lot of missing puzzles are also there. Say, when US or Europe come with the technology and an Indian come with the technology, there are huge difference between these two from an outsider's perspective. So these are few of the missing puzzles that we need to really work on. And the another opportunity and challenge is about the expertise. So when I kind of introduced myself, the beginning I told I kind of work with people from multiple interdisciplinary background. Even my group is also having people from max, people from sociology, um, so anthropologist. My one of my PhD students, she is working on climate and health. She is an anthropologist, and another student who is working on agriculture and emissions. So he is the social guy, sociologist. So his masters and his degrees are from social perspective, because we do work on interviewing the farmers. We need to collect the qualitative data, and we need to try to develop models. So I do have students from mathematics background, applied mathematics background. So it is good to work with different expertise, people from interdisciplinary background, to find a proper solution. And I have mentioned there are three major problems when it comes to AA in waste management related research. So those three are, one is black box, another one is lack of data, and another one is lack of suitable models. So this black box refer to the artificial intelligence models, which makes it difficult for researchers to understand their mechanism. So mostly the how it is functioning, that becomes the black box. So because I am not the expertise in this artificial intelligence or its mechanism, I do not have enough information on this, but I do heard from people or my students who are working on AEML. So most of the times when I ask them to explain how this particular code is ending up with this thing, I have seen them struggling, or I have seen them mentioning that few of the things are black boxes. Still, we don't know how it is working. Next is lack of data. This is something very, very important because we have experienced this when we are doing this smart city project. So though they have this ICCC unit, when you ask them the data, they don't have. They don't have, in the sense they are collecting the data, but those may be in a different format. When you want the data, it has to be in the number. So there is a format that you need, but they have it in a different format. So these are some small things that ends up in an idea of not having enough data in India. So this is something that we really need to work on. Then a suitable model. So this AML things are kind of every day they are kind of coming up with new new models, new way of writing the codes, the shortest codes possible. Okay, so and the which can reduce the running time of the codes. So few codes it will take 4-5 days to get the output and the first figure, and a few codes when you are trying to enhance your system, or when you are trying to connect your code with the supercomputer, you can see the process time becomes so low. So there are few things that we need to, or a lot of things that we need to address when it comes to the selection of suitable models which can function efficiently to give quicker output and accurate output. So both are very important. So these are three problems in research and interdisciplinary collaboration, as I have mentioned. So this is all about the first one, the research, the opportunities and challenges. It is about research. So the next one is about the technology part. The technology part. In waste management. So here I'm not going to talk anything about artificial intelligence because I don't work on it as a core. And the technology is about waste management. So when it is about choosing a technology in waste management, a lot of technologies are available. So just if you enter the key waste technology in Google, you end up in having multiple techniques and technologies that includes right from the generation of waste, composition of waste, transportation of collection and transportation of waste, source segregation, uh, the processing units, treatment techniques, dump site problems, fires in dump site, resource recovery. So there are n number of problems that need to be solved in any waste management technology, and so the technology development. So there are n number of, for one problem you end up in 100 technologies. The second problem you end up in another 50 technologies. So now which one has to be chosen? So that becomes the major problem statement for anyone who is working on AML, because you have lot of input to give. Again, it is about the complex system modeling. There are multiple components that are involved in this kind of problem solving. To add on just to one more thing, pre-treatment steps. Say anaerobic digestion, if we are going for a pre-treatment step, it can enhance the efficiency of the digestion process as well the biogas generation. So just we are adding the pre-treatment as one more the component. Now we really need to look at what are the different pre-treatment options are available and how those are enhancing in the two terms I have mentioned. One is the digestion of the waste, another one is the biogas generation. So now you can see there are multiple arrows that are being connected. Further makes the system complex. So every time we include a component, the system becomes complex, even more complex. The most complex system, you end up in need of some modeling, some interventions of AI and ML to solve the problem in an efficient way. Again, we need data, lot of inputs. So the third is about, so we have completed research, we have completed talking about the technology. Now we are going to talk about the economy part. So as I have mentioned, when we are talking about the sustainability of anything, there are three things we need to remember: environmental sustainability, social sustainability, and economical sustainability. So this economical sustainability is anyone's choice more than environmental sustainability and social sustainability. Say we want to have a startup. So our ultimate focus is getting profit, not to satisfy the society, not to take care of the environment most of the cases. Even the startups which has the ultimate goal of safeguarding the environment or eco-friendly something, their ultimate aim is to have the profit out of that. So this economical sustainability makes the prime and the most important one behind every decision making process. So when we are talking about resource recovery, when we are talking about waste management, always we need to include the benefits, the economical benefits. So in the very first project statement that I have provided is on e-waste management. So I have quoted this there also. So before going into the recovery process, before selecting the processing techniques, we need to really check the cost benefit part. So what is the cost that are involved in recovering that precious metal? Now the precious metal is recovered. Now what is the benefit, profit we get? If the benefit is more than the cost, we end up in profit, people are happy. When the cost is more than the benefit, people are in the losing side. So no one will buy your technology that you have developed. So that is very important before starting any kind of research. So the same applies here also. So the cost benefit analysis is the first thing that we need to think of, because people are ready to compromise environmental sustainability, social sustainability, but they never compromise on economic. It is not only about people, it is about the government also. It is about everything. So we have to make sure of the economical benefit of any technique. So this includes two things. One is the implementation. Implementation is about initial investment, operation cost, maintenance cost, end of life disposal cost. And the benefit is about after selling the recovered product or the technology that you have developed, how much money you can earn out of. Okay, so say an example. So this is one of the solar based treatment technology. So here you can see there are multiple metals that are being available in seawater, concentration in seawater. And when you are trying to apply solar based technology, you can see a lot of concentration is here. So here, sodium, magnesium, potassium, calcium, it has huge amount of concentration compared to the other metals. You can see here Ag is here, gold is here. So gold, silver, germanium, gallium, all these are precious metals. So when we are trying to recover precious metals, you can see this line. So this is the line where this is the break-even line, which can clearly say economically challenging, economically feasible. So sodium is like sodium chloride, salt. Okay, sodium. So sodium versus gold. So generally we go for gold because gold is precious. Sodium is not a precious one. Okay. So, but based on the concentration, the decision making is completely different and it is quite contradict, right? So here, based on this model, we understood that it is better to go with the non-precious substances, inorganic substances, rather the precious metals recovery from seawater using this technology. So this is the simplest version of how we need to really look at the technology versus its application when it comes to economic profit or economic benefit of anything. So here also AAML's role is very influential and economic and important. And next is about societal thing. So society, it's about employment opportunity. Whenever we develop technique, it is all about employment opportunity. How much living standard, better living conditions you can provide. And because of a particular technology, what kind of secondary waste or emissions that are being released. Say, we are very much interested in having industries. Say in Chennai, we have Ambattur industry. That is an industry hub. But if you see the water, the groundwater pollution, it is huge. even in Cochin, you can see the condition of the few ecosystem, which is completely because of this urbanization problems. Because of the benefits where it is located, when it comes to geographical location, it escapes the air pollution. Else, Cochin may be one of the city which may end up in having worst air pollution because of this huge activity. Okay, so sometimes the geographical location favors us dissipating the air pollutant. So this society thing, we have to talk about the positives and negatives. So the sociologist people generally used to do a lot of research on that and develop the data really helpful in making the policies and legislation. Then it is about environment. So I have talked a lot about environment. So we can do a life cycle analysis to understand the real benefits or real impacts of any system to make the final decision. All these end up in lot of data generation. So one life cycle analysis, if you are taking at least 20 indices, it at least end up in at least 10,000 data it ends up in. So that needs further processing and optimization. So generally we do go for different models that include statistical models and other simple models. So but AML can play a huge role in all these things. Legislations, as I have mentioned, so when it comes to researchers, technology, so they can give input on what kind of technologies that we need to follow. Say drip irrigation system. So wherever the water scarcity issues are there, we end up in having drip irrigation system and the government started giving subsidies. So drip irrigation system is a technology or technique that is being developed by the scientists or researchers, technologists, engineers, and the subsidies that are decided by the social people, the people who are working in the ground, meeting the farmers. So they understood that these are few things that farmers need subsidy. So now the subsidies are given to the people who are kind of installing the solar based system from the central government. So these are based on multiple field research, technical research, finally comes to a legislation of different nature. It can be a simple rule, simple do's and don'ts. It can be a subsidy, it can be a manual, it can be anything, tax policies. So now we are talking about carbon credits. The industries are very much interested in developing the system or following a particular system which can gain them carbon credits that can be used later, or they have to neutralize the carbon emissions that is being generated because of these activities. So these are all helps in government and people and the industries without compromising the people's life and their functioning. So I just so mostly I try to complete all my presentations with these 2 slides. Okay, so there are a lot of things hidden. Okay, so when it is about AI and ML, I have just quoted very few things within the time given, but there are a lot of things which are hidden. We can see just the small leaf outside, and uh, we are lot of things to do in AI and ML perspective in waste management, not only in waste management, in the entire environmental engineering. Because I'm working on different problem statements in environmental engineering. Every time we end up in data, every time we end up in having a problem statement that requires the secondary knowledge from the people who work on computational modeling. So more the things we are having, more the problems that we are having to interconnect with, to work with, we end up in having multiple problem statements for the people who are working on computational things. And this is my last slide. Potential means nothing if you don't do anything with it. Yep. Thank you. So with this, I complete my talk.
Yeah, dear participants, if you have any queries, you can interact with resource person.
Hello, ma'am. I'm Seema Srivastav. Ma'am, recently I have worked on e-waste management. So I found that real awareness is not there among the people. So analysis of that only. Can you suggest any tool to calculate carbon footprint of it? Like in daily routine, people are using electronic items a lot. household items, and then we just trying to find out how much carbon footprint will be there after 5 years, or like currently they are producing. So do you know how to do that thing?
Okay, so you have asked 2-3 questions. You have compiled 2-3 questions and asked us a single question. So I'll try to answer one by one. So your question is about carbon footprint of a particular product after 5 years emission and during maybe its production or its disposal also. So what we do is, you must have heard about life cycle analysis, right?
Yes, ma'am.
Life cycle analysis. So this life cycle analysis gives the perspective from the basic supply chain. So you need to make a supply chain, then you need to check each component of the supply chain and carbon emission is being generated from the supply chain. So then you need to do some calculations to understand this carbon footprint. So how to do that? There is a software available. So there are multiple techniques that are involved, but I can just to show you this software, OpenLCA. This is a open software. Okay, so you can install it and you can learn the basics. But you should really know how to do this life cycle analysis to work with software. So I thought of conducting one maybe seminar or workshop at the end of December or at the end of January. Maybe I'll pass the information to Professor Ravi so that he can provide more information on. So something that is useful. The another thing is, you have asked about the people's thing, right? When someone is using how to measure their carbon emissions. So there are multiple carbon emission calculators are available. You can just type. These are all simple websites like webwares they have used, but these data are like not updated. Like, see, they have taken the data from somewhere and they try to do the thing. So here you can see for different countries. So for a person, again, you may need to just enter here carbon emission calculator for an individual. Okay, so you can end up in a few
Ma'am,
websites.
how can we verify that whatever value is coming? Like we have to verify it, no? With
No
how
way.
will do that?
That is the problem. That is the problem in most of these calculators. Whereas these software, so you can use the authentic one, United Nations carbon footprint calculator. So to an extent, you can get the right number here. So just to check when they have what kind of data they are using, say here household transport and life cycle. So you need to just give the information here, but you cannot expect them to be like very very kind of detailed one. It's a very brief one. Okay, but when you work with this OpenLCS software, so here the databases are updated one and you can rely on this software, because I have seen researchers working with multiple paid softwares, but paid softwares always, yes, of course, they develop the database, they pay a lot of money for developing their database, but this OpenLCA is a open one. Still researchers add the data to this OpenLCA. Even when we have done some work on agricultural emissions, they have contacted us to give our data to incorporate in their work. So when it is open, people also very much generic to give their information to them, most of the people at least. So you can just explore in this direction. So you have asked 3 questions. One is product emission. Another one is when it is used for 5 years, how the things are changing. Third one is life cycle. I think I have answered all the 3 questions.
Yes, ma'am. Thank you so much. And one more thing I want to ask, like how we can use AML or other technologies for rack pickers, like rack picker childrens or their families. How, because they are like having lots of health issues, lots of the livelihood they live, they deprive from education as well. So how we can use technology to have because they are also part of society, so they do have an equal right to access education and other facilities as we have. So how we can use technology to have this equality?
Okay. So I hope you must have attended this talk from the very beginning. I have given a disclaimer that I am an environmental engineer. I do work with people who works on AI and ML and who are expertise in AI and ML. I don't have any knowledge on AI and ML.
No, no, I know you have told that thing, but I just wanted to have, because you have real life experience with that. So sometime maybe you have some in your mind, we can solve this problem like this, something like that.
The sustainability concepts, yes, I do can answer, but not the AML perspective. I really don't have the idea how it works.
Yes, ma'am. With respect to sustainability, then.
Okay, so sustainability perspectives, if you want to learn, so you can just go to this UN SDG site, and you can just see here there are 17 goals, and every goal has.
Yeah, I know, ma'am. I have read about this. I have
So
know all the 17 those.
you must be knowing the indices, right? How to measure those indices and how to work on. If you know this, you must be knowing that also.
No, ma'am. But in reality, how we can help out? Like, I just wanted to know from your perspective, your insight for that.
Okay, so it is not only my insight, so it is about the United Nations insight also. So here, why I am just showing this is because there is something called, everyone knows the 17 UN SDGs, but most of them, they doesn't know the indices that are being involved in this. That indices give you lots of information. Say this poverty eradication, you can just go here. Milestones, publications, you can read the publications also. That gives us a lot of information on how to, say, if you are looking for child poverty, free the child from poverty, you can read this. If you want to work on the free the women from poverty, so you can work on you can read those documents as well. But I am just checking the indices which I was mentioning, that will give you an overview. Yeah, here targets.
Okay, ma'am. Thank you so much.
Okay, so here you
Yeah,
can.
indicators and targets are there. Yes, ma'am. I have actually, after my PhD, I am more into sustainability. So I'm currently pursuing MA also from IGNOU, no, in sustainability science. So
Okay.
in my first year, that complete paper was there on SDGs, no?
Okay, very good.
So,
So basically, we need to work on the systems which can enhance us these indices. So basically, and there are a lot of contradictory statements also against these indicators, because you must have, because you are working on sustainability aspects, you must be aware that all the time only a few countries are topping in this ranking, because they have made, there are few theories that says that they have made the sustainability indicators in such a way that favors those countries. Okay, so basically, if we want to, if you are really looking at developing or improvising the system and moving towards meeting these goals, you have to just look at the indicator. So what this indicator talks about, so you have to just work on that portion. So what, say, eradicate extreme poverty for all people everywhere, currently measured as people living less than $1.25 a day. That means $1.25 at least everyone has to get, or more than that everyone has to get in a day. So you need to work on the job opportunities and other things which helps them getting more than $1.25 in a day. So this is the simplest version of saying that. But again, the people who works on policy, the people who works on social perspectives and the industries that we are trying to bring into India, so that really matters. But if someone is getting a dollar of $1.25 per day, and if you are telling them, if you are announcing that they are above the poverty line, that is not right. What if they are spending that $1.25 again on the health perspectives, just to maintain the health? That is what your question is about. The health is declining. So in that case, it becomes zero. So you cannot just keep this kind of indicators as the generic one when it comes to implementation. So there are a lot of things to talk about. Yep.
okay, ma'am. Thank you so much, ma'am. Thanks a lot.
Yeah, madam, I have one question. This is Santosh from IIIT Kottayam. I'm also associated with industry.
Okay.
So regarding mining, mining, what we have observed, there is a lot of, in aluminum mining, there is lot of waste which is produced as red mud. So is there some development which has happened, some initiatives to manage this red mud?
So we need to really understand the characteristics. So when you are calling something as red mud, we should know the characteristics of that red mud, which is kind of varying with location to location. So when it is about mining, the major challenge is, say, gold mining. So the recovery is aiming for gold, but the waste is something that is very much related to the subsurface condition and what kind of mining activity they are doing and how deep they are going. So generally, this mining wastes are having different characteristics. It changes from location to location. We really need to understand the characteristics of this red mud So then we can suggest some alternative measures to mitigate the pollution or manage it.
Okay. Okay.
One more thing, ma'am, I just wanted to add in your knowledge because you told that in India it is not possible to develop 100% segregation. I have seen one conclave was there on plastic recycling in Delhi this year only. So there Ishitwa, one of the company, which is Gujarat-based company, and they have put up their machine. So that machine is using AIML only that is working. So it's segregating 100%. If you want to have suppose red colors of that what you can say bottle caps or something like plastic polyth bags or milk bags you want to segregate from entire waste, so that machine is 100% doing that thing. So people are coming up with segregation. The only problem is awareness, means
So
the
it is
normal people don't have.
type
So
based,
that is already developed, ma'am. That machine is, I have seen that working in that conclave.
so it is the plastic type
It wo-
or
Ma'am, yes, ma'am. You can segregate based on texture, based on color, based on material, everything they have, ma'am. You can just feed those things what you want from that waste material. It is separately segregating those things, and which you don't want, that is separating from the entire waste. That I have seen. That demo was there in Conclave. Ishitwa, ma'am, you can search that company. Is it Gujarat-based company, ma'am?
what is the company name?
Ishitwa, ISHITVA. Ishitwa.
Oh, okay, I'll pass the information to my colleagues. Thank you.
Yes, ma'am. Thank you so much, ma'am.
Yep.
Any queries, or anybody want to interact with the resource person, please?
Hi, ma'am. This is Lakshmi. I was pursuing my research from Cochin University of Science and Technology, and I was doing my work in AI only. So,
What?
hello, ma'am. Is it audible?
Yes, you are audible, ma. Please go ahead.
But I just want to know
ma'am.
where you doing your PhD?
In AI only. In my area was transfer learning. So I'd like to know what are the prerequisites that are required if I want to switch my or if I want to continue my research into AI in waste management.
Oh, no, which university you have mentioned? Can you please repeat? I missed that portion.
No, ma'am. I was working for transfer learning. My area was transfer learning only. And initially itself, I was very much interested in this waste management. So I would like to know what are the prerequisites required, because when I go through the PPT, I understood that you require some interdisciplinary areas if we want to work in this particular area. So can you please tell me what are the prerequisites required?
Okay, are you doing research or are you doing your master's?
No, research only, ma'am. I'm about to complete my research, and that too in transfer learning.
Okay, so basically you are a core AAML and computer science background.
Yeah, ma'am.
Okay,
My
see,
core was it.
okay. I have mentioned I do interdisciplinary research. That doesn't mean that all the student has to be from multiple backgrounds, multiple discipline backgrounds. Basically, what I meant is a student who is having the core expertise on AAML, they will work only on AAML. But they need to have when we are explaining this is our problem statement, they have to have a basic skill to understand those problem statements. So generally, when someone joins here at IIT Hyderabad in my group, suggest to them such courses. Say the sociology student who is working under me, he has undergone the courses on LCA, on sustainability, and 1 to environmental engineering courses. So it doesn't learn anything on design, core design aspects of environment, but we do make sure that he is having the basic idea of what he is working with. Because then only they can actually implement their idea. So because you are interested in this application of AAML in waste management, I suggest you to go through some of the NPTEL courses that are available. So if you are a master student and if you are looking for research, then I could suggest you in a different way. But now you are about to complete your PhD. So try to go through some NPTEL courses on waste management. So you will get some basic ideas of how things. So that may help you in at least make a decision on whether you should really switch your things from whatever you are doing now to waste management. Yeah.
Thank you so much.
Madam Santosh, hello, Santosh here back, madam. Madam, I just wanted to understand, is there any research, on because you must have seen that this EV adoption is increasing in India, and with the EV adoption, so there is a risk of this battery. After 4 5 years, disposal of battery will become one of the most hazardous.
Yes.
So, is there any research work how to control?
We have just started some task-based research because EV, the owners are very less and almost all the batteries are in running condition. So we have just started some task-based research, like what are the components that are involved, how much of components that can be recovered, and what are the emissions that are being expected if we are dumping them into dump site as such. What are the things that can be directly refurbished and use it in another e-vehicle battery. So we have started some task-based research, theoretical research. But I do not see because so far it is not waste. If everything is running, at least in India.
No, no, it's not a waste, but maybe after 4 5 years, when
After
life
4 5
cycle,
years to be a
yeah,
major. We are
then
having solar panel as one of the major problems now. So we have started the solar based things installation around 10 15 years back, and now the solar panel waste is one of the huge
yeah,
waste treatment that we are looking at, right? So similarly, this e-vehicle based battery is also going to be one of the issues very soon. So we have just started few things.
and this lithium mining is also something which government is promoting. So I was going through one of the article which says that it will means that emission of carbon dioxide will become is very higher.
Yeah,
Says that 1 ton of lithium nearly emits around 15 tons of carbon dioxide.
yeah. So, yeah, I think you be aware that a lot of research is going to be on, and already is happening on sodium batteries also. So,
Yeah, yeah. Some of the some of them have come up with sodium batteries solution.
so here one two companies are working on sodium batteries. But still, see, they are all in developed stage. E-vehicle, they at least in India, this e-vehicle. I remember when I was doing PhD in IIT Madras itself, they have done an exhibition on e-vehicle.
Right.
That is around 2010. Okay, so but just now, like past 2 years or 3 years, only people are really buying e-vehicles. So this takes this much of time to convince the people, and still we don't have enough charging points, and the battery's capacity also is not so encouraging, like to take a long travel. So a lot of things are still needs to be addressed in e-vehicle. So people are working on the batteries related issues. So the more focus is going to be on that side than this e-waste management. So
Yeah, that is all because I'm in that industry itself. I manage semiconductor.
Okay. So you are in.
So EV, what is happening? There are a lot of startups which has come in, and even Tata's and other like Tata Power, and they're actually expanding the network. They're laying a lot of charging station. I'm working very closely with them.
So basically,
So they are, and even they are increasing the life cycle. Means the kilometer, mileage.
Capacity, yeah.
Capacity of the battery. They are also working on that side, and they are expecting that we will have higher mileage of batteries, which come up in future. That is already been worked out. You must have seen companies like BYD. They give you a much higher mileage, in terms of any charge, and even fast chargers has come up which can charge your vehicle 30. Those technologies have already been developed. Now, the second thing which everybody is looking at is the e-waste management, the EV, the batteries which generate and how to handle it.
Yeah. I understand your question. But even if you see any proposal call, even recently there is a proposal call from Ministry of Mines. They talk about resource recovery, but they did not include EV batteries. You can see that they have included all the e-waste, but not the e-vehicle battery. So because our focus is more on, see, we are launching multiple satellites. Okay, so if you talk with anyone, the scientists in ISRO or any defense industry, if you are talking about the e-waste that is being generated in the atmosphere, are in the space, no one bothers about. So they just say, see, we are still in the technology development stage. We don't bother about the disposal of something which is not in our purview as of now. So the same matches with e-waste, I mean, e-vehicle at least. See, past 10-15 years, no one talked about the solar-based waste.
Yeah, that's it.
Like how we are talking in the past 3 years. So once the problem comes into the peak, then we all talk about that. But to your knowledge, there are people who have already started working on this e-waste, e-vehicle batteries waste management, because already we have started research on different e-waste, including our group. Yep.
Right.
And a lot of people are working on developing the alternatives also, like sodium batteries.
Yeah.
But again, that may having multiple other impacts that we really need to look at. We cannot just say sodium batteries are replacing a lithium-ion battery in all perspective.
And the cost is very high currently. So,
Yeah,
that is one thing. That is another factor which is there.
yeah.
And a lot of research is there. It's not reliable still. That sodium and batteries. The reliability is one of the biggest factor. But research team is working another on a solid state battery, which they expect by 2030, all the batteries will be replaced by solid state battery, and it will give you much more mileage. Maybe means with a single charge, one can travel a distance of more than 1200 kilometers.
Yeah, it is something like how our laptops are getting.
So solid state is something which will take off because I was working very closely on this. So by 2030, I think this will come up, the solid state batteries.
Good to know that. Yeah, but again, that may end up in the another ways that we need to.
That's right. So once a new product coming, we have also to think about how to manage the waste, because it will be definitely generate a waste after 4 or 5 years.
Yeah, that is what I was quoting in the research. When we are working on waste management, it is a forever problem statement. So few people think that waste management is the oldest area that environmental engineers used to work. It is not. So if product is launched in the market, that means that 10 years down the line.
In India, we think like that because I worked very closely with Japanese firm. They think on both the verticals at a time. Once they generate a product, they also look at how to handle those wastage of those products after a couple of years after their life cycle.
Okay, then thank you.
So that is one challenge here.
I think it's time.